Question 4 is graphing question. So what they've given us, sketched below, is the graph of f of x equals 2 to the x minus 4, so an exponential graph, for x is an element of minus 2 to 4, can equal minus 2 and cannot equal 4, which means that this is a restricted domain graph, guys. So just by looking at the question, we already can see that this graph doesn't go further than minus 2, and it also doesn't go further than 4 in the domain. Okay, A and B are respectively the y and x intercepts of f. Okay, so y-intercept A, x-intercept B. First question, 4.1. Write down the equation of the asymptote of f. One marker, asymptote of f is minus 4, and that we can see straight from the equation. Okay. The q value, or when you plus or minus a value to an exponential graph, you are vertically shifting it up or down, and in this case it has been shifted down by 4, which means the asymptote is at y is equal to minus 4. 4.2, determine the coordinates of B. Now 4.2 is a little bit of algebra. B is the x-intercept, guys, so when we're working out x-intercepts, how do we work that out? We make y equal to 0. Okay, so we are going to say therefore 0 equals 2 to the x minus 4, therefore 4 equals 2 to the x. When we're dealing with exponential equations, we're looking for the same base. Drop the mic, drop the base, so 4 can change into 2 to the 2, and we have the same base of 2, so 2 is equal to x, therefore b is 2 and 0. Okay. 4.3. Determine the equation of k, a straight line passing through A and B in the form of k of x. Okay, so k of x is going to take the form of mx plus c, because that is a straight line. Do we have A's coordinate? No, we don't. That is the one point that we will be needing. So how do we work out y-intercepts in graphing? We make x equal to 0. So we're going to make x equal to 0 in our exponential graphs equation. So y is equal to 2 to the 0 minus 4, which is equal to 1 minus 4, which is equal to minus 3. Okay, so A's coordinate is 0, minus 3. What you can also do, guys, is you can write that in your drawing itself. Just for later, we might need it, and we don't have to look for it. And this is 2 and 0. Okay, now it's pretty easy to be able to work out a gradient from that. Gradient formula is y2 minus y1 over x2 minus x1. More than welcome to do rise over run method as well, but I think a lot of people prefer this one. So it's going to be y2, so let's say 0 plus 3 over 2 minus 0, which is going to give me 3 over 2. 3 over 2 looks right. The gradient that I will be getting there is a positive one, and I got a positive one as a result. Now, what's nice about this one, we've got k of x equals 3 over 2x plus c. Now, everybody, plus c is our y-cut, y-intercept. And do we know where this graph is cutting the y-intercept or the y-axis? Yes, at A. So basically what it means is it means that the exponential graph and the straight line graph share the same y-intercept. So therefore we don't have to do any working out. We can just say 3 over 2x minus 3. And that is my straight line equation of k of x. Okay, awesome. Fantastic. Let's move on. I'm just going to move it across and we're going to carry on with question 4.4. Okay, so 4.4, what are we looking at? Mark allocation, 3 marks, okay? Calculate the vertical distance between k and f at x is equal to 1. Okay, so let me just draw in this graph quickly just so that we understand it. And you guys are more than welcome to do this as well. Let's draw this graph and it's going to look something like that. Okay, so what are they wanting from us here? They are wanting us to work out the vertical distance between. So 1 would be somewhere here. This is 1. So they're wanting to know the vertical distance, that distance over here. Okay, a little bit of a small distance, but that's what we are wanting to work out. So at x is equal to 1, we are working out the vertical distance. When we're working out a vertical distance, guys, what we do is we take top graph and we minus bottom graph, okay, normally. But in this case, because we know the x coordinate, Do you agree with me that all we need to do now is work out the y coordinate when x is equal to 1 for the straight line, and the y coordinate for the exponential graph where x is equal to 1, and then just minus the straight line graph from the exponential. And that's what we have to do. So we are going to say k of 1 equals 3 over 2, 1 minus 3. That is going to give me 3 over 2 minus 3 is minus 3 over 2. And then f of 1 equals 2 to the 1 minus 4, which is equal to 2 minus 4, which is minus 2. And then all we are going to do now, because we're dealing with distances, guys, there you can't get a negative distance. So it means that the difference between 3 over 2 and 2 is going to be, okay, so the vertical distance, oops, spelling shocking, vertical distance is going to be equal to 2 minus 3 over 2, which is going to give me a half. So a half units. Okay, and that is how we would work that out. Signage-wise, you can do it with your signs. You can say top graph, which is minus 3 over 2 minus 2. Okay, and then that can also give you a half units. Gets a little bit confusing with the signs. All I say to myself is that, you can't have negative distances. So just take the values and minus the one from the other to get the difference. Okay, cool. Great. Let's move on to 4.5. 4.5, write down the equation of g if it is given that g of x equals, and I'm going to write this out so I can explain it, f of x plus 4. Okay, so g of x is the result of taking f of x and plussing 4 to it. Remember I told you before that when you plus or minus a value to a graph, you are vertically shifting it. Okay, so in this case, all we're going to do is we're going to plus 4. It's actually a very quick answer. Therefore, g of x is going to equal 2 to the x minus 4 plus 4. So this is actually shifting it to the parent function exponential graph. And don't forget about the domain that it exists in. We need to state that because it has been restricted. So x is still an element of minus 2 to 4 close bracket. Okay, and that is the final answer for 4.5. Okay, cool, 4.6. Okay, so these domain questions are going to get a little bit tricky. Main reason, and something that we mustn't forget, and a lot of people do, is the restricted domain given to us. Okay, so what we would need to find out is we would need to find out, okay, well, what are these coordinates? I know that this coordinate, and I'm going to write it in here, this is going to be, oops, let's use the pen. This coordinate over here is minus 2 and something, and this coordinate over here is 4. So what I would like to do there is actually work out the rest of those before I go into this question. So let's do that for 4.6. You don't have to show it as a question, but you do need to, as an answer for this question, but it would be advisable to have it. So let's actually do it here. It doesn't have to be part of your answer, but if I wanted to work out minus 2, it would be f of minus 2. So f of minus 2 is going to the minus 2 minus 4, which is equal to 1 over 4 minus 4, which is equal to a quarter minus 4 is minus 15 over 4. And if I sub in, minus 15 over 4. And if I sub it into the other one, f of 4 equals 2 to the 4 minus 4. And that's going to give me 2 to the 4 is 16 minus 4 is 12. Okay, so that's going to be 4 and 12. Awesome. Okay, now what's going to happen is we are now going to, let's put that there. Okay, so now the question here for 4.6, write down the domain of g to the minus 1x. So g to the minus 1 of x is the inverse of g to the x. Okay. So what's important about inverses, guys? X's and Y's switches, but also your domain becomes your range and your range becomes your domain. So do you agree with me that if they are asking for the domain of the inverse, it means you can give, it'll be the same as the range of the g of x graph. Okay, now g of x graph was the original one, so let's draw that new graph in. The g of x graph would look like this. It's basic parent function exponential graph. Okay, and these points would have changed a bit. So yes, this was minus 15 over 4, but that's all been shifted up by 4 now. So if I plus 4 to that, it gives me a quarter. So this new coordinate is minus 2 and a quarter. And if I take my new graph, if I had to go up all the way, let's pretend that that goes there now. It's now going to be 4 and 16. Okay, so it means that the range of my, and I'm going to write it here, the range of my g of x graph is minus a quarter, so not minus a quarter, just positive a quarter, so it can equal, so y is an element of, can equal a quarter but can't equal 16. Hard bracket, soft bracket. Now that means that the domain of the inverse will be that. So my answer for the domain of g to the minus 1 of x is going to be x as an element of a quarter to 16. Okay, and that is my answer for that question. Awesome. Now we can do 4.7. It's asking me to write down the equation of g to the minus 1 x in the form of. Okay, and that one isn't so bad now. That is your standard form. So we're taking g of x, which is equal to 2 to the x, and the inverse of that would be log 2x. Remember that x is an element of x is an element of minus 2 is to 4. Now this means that my domain for this one we worked out before is a quarter is to 16. So that is my answer for that question. Okay. Not too bad. A little bit tricky there with the inversing of a restricted domain graph. Okay. But other than that, not too bad. Okay.